Hello everyone, Kieran Ovasakin here from Filmstorm Studios, and we're bringing you part 2 of the root motion system in Unreal Engine. And as you can see, we left off with creating the third person character blueprint for the actual movement calculation. And as you can see, we wrote our comment and we basically did the math to get the input relative direction to where the player is facing compared to the camera forward vector. So if you have all of this done and we've set up all the variables, the next thing we need to do is to then set up the animation blueprint and transfer these variables into that so then the animation system can use it. It's quite simple. So to find out which animation blueprint you're using, you can actually come up to the mesh which actually drives and has the animation on it, and you can come over here to animation and it says anim class, and then this is the one that's that your character is actually using. So it's called ThirdPerson_anim BP_C. So if you click this little thing, it says browse to asset, and that will just bring it up in your folder. So it's usually in mannequin animations and in here, unless you're using a custom one, but because we're using the one from the template, it makes it a lot easier for us. So let's double click on this and boot that up. And as you can see, we get this screen, and you can actually dive into this, and this is the anim graph. So if you're familiar with Unity, this is actually like quite similar to Mechanim and how the little groups inside that work. But I do find this one to actually be a lot more handy and easier to manage. So this is the overriding state that usually just comes as default. And then this is the entry. So this is where what the game starts on and goes to this first state, which is going to be the idle or run. And then there's this one that's all been pre-set up, but we're going to come and change all of this later. So we won't really focus too much on this. This will be in the third part. This is like pretty much the final part of the tutorial, like syncing all the animations and making it look good. So in this tutorial, let's focus on setting up this one, the event graph. So basically what we're going to do is actually we're going to just we can actually probably keep a couple of these. We can keep this one, we can keep try to get pawn owner. Let me just bring this so we all have a little bit more space. We can keep is valid. We can keep the falling because we're still going to use that, and we're going to actually just blow away all of this because we don't need the speed. And let's just get rid of this comment. Okay, so what we want to do first is we'll just move this down so this is all good. Alrighty, so let's keep that there. Okay, one thing we want to do first is let's actually just initialize a character reference, which will actually just hold the actual character. So in case we want to reference the character at any state, we can just plug this in, which is really handy and saves us dragging lots of lines everywhere. So if you go event, you can see we've got 4 different things. We get begin play, initialize, post evaluate, and update. We're already using update, so we want to use initialize, and we want to drag off here and say cast to third person character. Cool. And what do we want to use as the object? We want to try and get the pawn owner. And we actually want to drag off here and say promote to variable. And as you can see, it's actually created a variable type of the third person character. You can't really see it unless I really drag it out. I don't think it's actually going to widen it. But it's actually the third person character. So it's just getting a reference of our character and storing it in that variable. So let's just call this third person, what should we call it? Let's just actually just call it character reference. There we go. Cool. So now that's done, let's actually come over and start to work building this next thing. So what we want to do is let's just grab our new character reference. So get this, and we actually want to drag out here, and we want to get input X. So we're getting that the input from this system. So that's one thing. And then let's drag off another one, and let's say get input Z. So we're grabbing this. But we'll need to create two variables in here. So let's actually come through this left side now and start to create some of the variables we're going to need. We're going to need a isMoving bool. We're going to need another bool, which is a received initial direction question mark, and we need one more is controller sprinting. So we can come back and fix those ones up. Let's create another one, and except we're going to change this one to a float. I think the rest of them are floats that we need. So we've got speed already. We need a direction. We need to have our input X, and I like to put just anim, so I know this is just the animation one that's just coming in. Anim. And I think that's all we need for right now. So now that we have those two input X's, what we can do, you can actually just hold Alt and drag in, and that just brings in the set automatically, because if you just drag it in without pressing anything, you get the option. So that's just a little shortcut. And what we want to do is let's plug this in, and let's just drag this one over. And finally, let's drag the input Z across, plug this one in, and then let's connect these two. Cool. Okay. Now we want to also grab the character reference. So let's drag another one off, and let's just make a reroute. And we're just going to do the logic for the sprinting, so that way we can actually come back and then sort that out when we get a chance, once we do the logic. So we'll have to go back to the character blueprint. Oh, sorry, we want to get is sprinting from this one, because we actually did set up the is sprinting, but we just need to actually do the logic for it, so it actually triggers. All right, so, but we can just do the actual math for it. So let's just do a branch. So if sprinting is true, so let's drag this from the input Z up to here. So it continues up here. If it's true, then let's set the speed. So we're setting this speed to this, and it's actually going to be times. We're actually going to do a times float by float, and this one's going to be 2. But now we actually just need to calculate the actual speed down here. So let's just make a comment for this one. And what we're doing here is we're just setting the animation for forward and backward, and the left and right. So basically this is just driving that animation. But now we actually need to calculate the speed by getting absolute values. And how do we do that? Well, what we need to do first is let's grab the input X, the first one, and type in ABS for absolute float, and ABS absolute float. And what we're going to do, we're going to plus these together. So we're going to float by float. So plussing those two together. And then what we want to do is we want to grab this one and we want to clamp it. So we're going to clamp float, and minimum and maximum is 0 and 1, which is what we want. We only want a positive, because if you push the stick on a diagonal with this current system, it's going to plus these two together, and if you don't have that, it's actually going to make it 2. So the character will start zooming off to the side. So this is our little handy solution for that, and it's quite simple. Alright, so what we want to do is we want to plug this one into the top of here. So in case we are sprinting, if this is true, then we are going to increase the speed times 2, which will allow the player to actually start sprinting. Okay, and then if not, we just want to set the speed again. And if this is false, we're just going to set the speed. So if we're not sprinting, we just want to do that. Alrighty, so to start off now, let's grab a print string. Let's just debug this so we can actually see what's happening. Again, it brings in the duration. We want to break that and plug it into the string. Good, good. Alrighty, and let's also drag this out a bit more, and let's do another append. this one and plug it into the second, and then let's type speed anim and space and make it 0 so it doesn't print a lot of lines. You can leave that open. All right, so let's make another comment. Let's go and drag out here, and we want to call this one calculate speed by getting absolute values and adding them and clamping between 0 and 1. And then this one up here, we'll just make, drag this out, and let's just make, call this one if sprinting times speed by 2. Times speed by 2. So that way it actually feeds through to our blend space, and then we can actually put our sprinting animations on 2. So then when we press like the sprint button, it will double that, and then it will trigger that part of our animation. All right, so let's just make this one, what do we want to call this one? This is just debug. Cool, and finally let's plug this one into here. Groovy. Okay, what else do we have? Okay, we want to now do the directional input. And so if the speed is greater than a certain speed, then we want to set the direction input to the animation. So what we want to do first is let's grab from the print string and let's make a branch. And what we want to do is we actually want to grab from this speed, and if this is greater than, plug this into here, and if this is greater than 0.01, then what can we do? We can do another branch and if we have received, so we're going to use this boolean that we created. Oh, sorry, I actually held that. Let's get this. So if we have received the initial direction, then we want to come and do another branch up here. So if that's good, then we want to do this, and this condition here is going to be less than float, and this float is less than 0.01 again. And we're getting this from the speed. So let's just grab this one and plug that into there. So we're just getting that speed. And then if this one is true again, still, we're gonna then set this. You can actually drag it into the node, and that sets that automatically up for you. And we're just gonna leave this unticked because we wanna have this as false, because we haven't received any initial direction because we're less than the speed. So technically we're waiting to receive a initial direction. So with this false one, let's move this up. So with this false one, what we want to do is we actually want to set direction. We want to set that direction to the character reference direction. So we want to get that direction and plug that direction into this direction. Oops. Move this up. Okay. Cool. And now once we've set that initial direction, we want to then have a delay of approximately 0.1. And then we want to receive initial direction, and we want to have that as a tick. Okay, so let's just make a few comments so we can understand what's going on. We want to drag from over these nodes, and let's hold C. If speed is greater than 0.01, then set direction input to anim. Cool. This one is if speed is less than 0.01, then we want to reset the received initial direction for next event. And finally, this one we can just say we have received initial direction. Groovy. Alright, so if you hit a compile, that's all pretty dandy. And we can just call this one, we can move these ones out, and let's just call this the initialize. Initialize, I have no idea. It's supposed to be an I in there somewhere. Initialize. That seems right, but we'll go from there. All right. Okay. So there's one other thing we need to do, and this is the probably the most important thing for the whole system. And we're actually going to be creating the animation notifiers, so we can actually set this up correctly. But what we want to do is let's grab our target, so our character reference. We want to drag off here, and we actually want to get character movement. I'm pretty sure it's it. So we just want get rid of that one, and we just want this one. We want the blue one. And what we can do first is we want to drag out from here, and we want to say allow. So we get this set allow physics rotation during anim root motion, which is exactly what we want to do. So let's grab that one, and let's just allow. Let's get another one. So make this top one a tick. Cool. And let's print a string, because this one is actually quite important, so we can see what's happening. So to make this one, I have turned on. Let's move that. I have turned on root motion, and let's just make this 0 and make it easy. Let's just copy and paste, plug this one in, and I have turned off root motion. So basically what we need, we actually need something to trigger this to turn off and on the allow physical rotation when we want it to happen. Now, how can we do this? Well, let's just compile and save that one. And first off, let's just comment this. I like commenting because that way it actually kind of makes it block it out, so you can actually understand it a bit better instead of just seeing all these random nodes. So I like to make fairly detailed comments. So this is going to be control root motion input, which technically this uses the standard inputs for TPS character, but we'll turn off and on the root motion rotation when we need to via notifies. Okay, so basically, let me close that bracket. So what we need to do is we need to actually set up the animation notifiers to allow the triggers to fire correctly. So let me just show you how to set this up. So let's come back to the actual content folder. Let's come to the open world thing. Let's start with turn in place. And here you can see we've got our turn in places. So let's open this one up. And we want these ones, so we get the 135. First off, what we want to do is we want to enable root motion. There you go, so you'll get this, but if you come to character, animation, and process, and you turn on process root motion, you can actually see it in action. So what we want to do is we actually want to create something to say allow rotation after a certain point. And now the best time to actually do that is after he plants the foot and finishes his own rotation. So about there, we can right mouse click, add notify, new notify, and call allow, this one, allow rotation. And then we have to work our way through. So turn on enable root motion. So he's going to turn. Good. I actually find it easier just doing this because you can kind of see it. There you go. So we can allow rotation, Okay, we'll make one here, allow rotation. Make sure you keep coming and turning it on. It might actually be easier to do it without the enable on, which you can. Just make sure you come and turn it on after you do the notify. So enable. So now we have our right ones. Okay, allow rotation. So again, I'm just right mouse clicking here and using the one that we just created. Okay, so allow rotation. Okay, that one's about there. Allow rotation, enable. And again, you can, if you're not liking when the rotation starts, you can come and adjust the timings, which is that's why the system's really powerful this way. And I'm not sure okay, that one's just a nothing one. Okay, so let's just go Control Shift S, and that's just going to go through and save all of those animations that we created and edited. And finally, what we're going to have to do is go and work on the other animations. So let's come up to our walk. We've got our walk forward. So this one again uses root motion. This one's just going to always be fine, so that's fine. We've got walk start, so enable root motion. And let's make allow rotation from there. So that's a stop. So the thing with the stops, this one's also important. What we need to do is we need to enable root motion, and then we need to create a new notify. So new notify, and then say block rotation. So as soon as he stops moving, we're going to block the root motion rotation, so then it will trigger the correct starting animations again. So let's come to here. I think this is another start. Yes. Okay, so this is going to be allow and root motion, and then okay, allow root motion, and this is going to be another stop. So there, and we're going to make this one block rotation, enable. Okay, and allow rotation, enable. There we are. Make it allow rotation, enable. And block that rotation and enable the root motion. Alright, so we've done all of the walks now. Let's move on to the jogs. This is probably the most tedious part of the whole thing. So this one, let's just enable that root motion. We've got, okay, let's start. So it's going to allow him after he puts his first foot down. And we also have to create allow rotation. Start left. Okay, allow rotation, enable. And you might, if you miss one and the system starts to play, you'll be like, oh, okay, I can definitely see when I move that direction, I didn't set the thing up right, because the character it won't turn, he'll just start running off in a certain direction. So yeah, that's an easy way to debug it. So let's allow that rotation, enable. Start it, allow rotation. And we're going to stop it there. So block rotation. And block rotation. And block the rotation. That's a job. Okay, and finally, let's come to the idle. And let's just click on there, because yeah, he's just going to be chilling there. Let's go to the sprint. So we've got sprint forward, so this needs to be there. So we've got end, so let's make the rotation stop there. And let's make the rotation stop there. And then we'll make the rotation allow there. And left 90. So we'll make rotation allow there. Sprint back there. Allow rotation. Sprint 90. Okay, so we'll make it allow rotation. And allow rotation. Oh, and yeah, allow. Cool. Okay, so that's all set up now. We might as well dive over to the animation blueprint, and I think we also need to edit a few of the blend spaces. So let's come over to here. Okay, so now that we're in the blend space, what we want to do is actually come up to the horizontal axis, and this is where we can actually specify our different values. So we don't want it to be between 0 and 500, we actually want it to be 0 and 2, because 0 and 2 is actually going to be the top maximum speed that we can move, as we said in the actual animation for the sprinting. So this is the top speed that we can reach, the ×2 by the speed, and since we clamp the speed at 1, we know that the maximum can only be 2, because 2 times 1 is 2. So yeah, so make that 2. We want to actually make this 15 divisions, because I like to actually place the sprint here. So if we press play, we can have the sprint there, and we've got this one, which is I think this is a jog, and the jog is probably in the 0.8. So we need this, let's move it to the 0.8. I find this to be the best combination. And then we've still got our walk, and let's actually let's find this walk. Okay, so walk anim walk forward. So let's grab the anim walk forward and place that here, so that way he's always moving when we're in that section. And one other really important thing, you notice if I adjust this is actually how snappy the animations will play. And to smooth that out, let's actually come up to interpolation time and make this 0.9. So now if we hold shift, see how it actually smoothly kind of moves between those animations. So first it will trigger the jog and then go into a full sprint, which is a really nice little detail. Okay, so that's the idle walk run. We'll also need to edit the start move to actually adjust all of these ones. So let me just bring up this one. All right, so let's bring up the horizontal and vertical, and we want to call this direction and speed, in case you haven't had that. Let's make this 8, and speed, we want it to be 4. With a maximum value again of 2, because that's the top speed that we can move. Interpolation time for this bottom one is 0.5, top one is 0, because we always want to know what the current direction is. Alternatively, you could increase this a tiny bit, because if you want the player not to be able to switch directions super fast, that is also another thing. And we also want to change the interpolation type to linear for the speed. Groovy. Let's grab all of these ones, which I believe are the speeds. Yes, so we have jog. So we want to place the jog on all the jogs on this line. And you can see that this one is jog 180, left 90, just jog start middle, jog 90 right, and jog 180 right. And the same goes for all of the walks. So basically the shipped blend space is actually set up pretty much the same, except we just need to actually come to our TIPs, our turn in places, and set them up. So turn in place left 180, turn in place left 135, it goes there, turn in place left 90, turn in place left 40, and then I believe I just have the default idle in there, so I'll pop that there. And now we've got 135 right, 180, 45, 90, and let's just grab the idle. Where the I is up here, idle, 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 and pop that there. Actually, I think that's the wrong idle. That's the actual weapon idle. Might be this one. Nope. You know what? I'm just gonna go directly into the folder and find it. That's better. So there we go. We've got all of the start and things working. So let's save that one. Finally, we need to actually set up the stop move. And then in the next tutorial, we'll actually come and do the jumping and that other logic. So the stop move. I don't think I changed much in this one. I think I made this 2. I made, yeah, the max value again 2, because that's the fastest speed we can move. 0 and 1, average interpolation. This is linear. Interpolation time again was 0.5. And basically everything else was left the same. Very nice. Okay, so we've got all this set up. We've got all the logic working. Let's come and have a look at how to actually whack all of these states together. So first off, it might actually be easier just to blow all of this away. And let's just start from bare bones. So let's drag this in from entry. We want to create a new state, and we want to call this idle. Okay, so let's go over, and we want to find our idle animation and pop it in. So we can go to the asset browser, and as you can see, we don't actually see any of our animations, and this is because we're using the default package that came with the preset. So what we can do is we can actually come to here, and what we want to do is we actually want to find the default mannequin and come to rig. You can actually, if you don't see this, come to retarget manager, rig, humanoid, and this will pre-fill everything. It's really simple. So let's just come back, go to our open world, mannequin, go to our skeleton, humanoid, and save. Then let's go back to the blend space. Or I mean the blueprint for the animation. So we're going to this one, and this one we can't see any of our animations because it's actually onto the wrong skeleton. Even though they're technically the same, this is just what we have to do if we want to use our own animation packages without retargeting all of the animations, which we can do if you want to use the same skeleton. But since we don't have many in this skeleton, I'm just going to reuse and switch them over to the other one. So what we can do is we come over here, retarget, duplicate, retarget, and let's just pop this one into the open world. And now if we go into here, all of this is still the same. It's still got all the stuff we made. And what we want to do is we actually want to come to animation. And here you can see we've got all of these animations that we can now use. So if we go to the anim graph, and let's boot this one up, and you can see that this has still got the idle one that we made. Now we can actually find the idle. Can never find the one I want. Where is it? Is it this one? No. This one? No. Where is just, I want just the idles for it. Okay, there we are. That's the one. Okay. Cool. That way I can see the path. Okay, so we just plug this one into here. And if we hit click compile, that's going to do it. But if we go and try and play, it's actually going to look for the wrong one. So we need to find our new one. And let's actually just rename the one that we just made. And let's just call this custom. So that way we can keep track of this one and make sure that we're assigning the correct one. So if we come to here, you can see the new one, third person custom, click compile, and we'll also probably need to adjust our mesh. There you go. So if you click play, you'll see that this is all working correctly right now. But what we need to do first is we need to actually come into the we'll actually close this one down. We don't need that one anymore. And close these skeletons down, just keep it nice and tidy. Close that one and just come and open this one back up. Okay, so here we are, we're in now this one. Let's come and create a new one, and let's add a new state. I'm going to call this starts, and let's plug this one back into here. Let's then make another one. We're going to call this one the walk jog sprint one, which will then come down into the stop. Start the new state first, stops, and then plug this one into here, Ruby, and then we'll also create another one, which will be the jump to fall. And basically this can also be triggered from an idle, a start, and a stop, as well as this one. Cool. And then what we can do is we also want to have another one, which is going to be land to walk, jog or sprint. Move this one out here. And this one can also come back into here. But we also need another one from jump to fall, which is just a land to idle. So this is a complete stop. And this one can either go from here to here. Okay, so I think that all those connections are now made in the correct order that we need it. Bam, 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 yep, okay. So now let's go through and start building the actual poses in. So we want to use our BS one, and we want to use the start move. Plug this into here, and now nice and simply we can just get the direction, and we can also grab the speed and plug that in and save that. Of course it's going to give us all the errors because we haven't made any of the transition rules. We also want the idle walk, and that's also just that one. Groovy. Now let's go over to the stops and stop, move, grab that one, plug that in. Foot, we'll have to do some extra math for that later, but we can just use the speed for now so we can get a correct stopping. And for now, let's also just use, I think, do we have a jump? Okay, well, for now, let's not worry about this this one. I might actually just take out all of the connections to these ones. So that way we can actually, because we're going to come back to that. So we'll leave the nodes there. So we'll leave them there in the correct spots, but we'll just focus on the actual movement just for now. All right, so what we want to do first is let's come to the very initial one. So this is the one that's going to. So if you hover over that, it's going to say idle to starts. And what we need to do is we need to do some math. So we need to go from and say we want to find the float that is greater than. So that's going to, and then if this is true, then it's going to give us the result. So as we said in our logic, we want the one that's greater than 0.01. And I'm going to plug in the speed into the top one. And then for the one that's coming back, we're going to also do some logic. We're going to do an AND bool. And this AND bool is going to have the bottom one, which is less float, like that's less than 0.01. and the speed. There we go. So if the speed is less than 0.1 and the time remaining, actually we need to do just a separate node, time remaining ratio, make sure it's the ratio for the start move is less than 0.5. So if we're halfway finished with that animation, we should start to cross over and blend, and then that can give us that result. Okay, now for this one, what we want to do is we actually want to do pretty much the same thing. We want to do an AND rule. This one will be a greater than float, greater than 0.01. So if we're still moving, we can still transition in. So we can plug that in. And the time remaining from the previous node, the ratio, if the ratio is less than, if it's less than 0.3, then we can cross over into the actual movement. However, if this one, if the speed goes under, so if the speed is less than, if the speed is now less than 1, we want to actually start to stop. I made this 0.1 because this is this will give us a little bit of leniency when we go to the idle. Okay, so let's come to here, and for the stops we want to do the same. We want to do time remaining ratio be a stop, and if this is less than 0.4, cool, that will give us that. Okay, and we're actually almost there. Finally, what we need to do is we need to come and actually enable the root motion, because if we go right now, there'll be a couple of problems. We're kind of looking at the camera, which is what we don't want to do. We can actually fix that up first. It's pretty simple. We can go to third person character, use controller rotation yaw. We can just uncheck that and compile. And if we hit play now we're getting a proper camera. But you'll see, sorry, if I press the move, we're not actually rotating in the correct way that we should be rotating. So how do we fix that? Well, we come down to root motion down here and make sure you're in the anim preview. You just click edit defaults. You don't want to edit the preview, we want to edit default, and we want to say root motion from everything. And let's click compile, play. And there we go. So now we're getting the correct kind of thing, but you can see that we're not actually getting that additional rotation, and that's because we haven't actually set up the animation notifiers. So we're getting the correct thing, but you can see how that rotation is important. So let's come to the event graph. Now let's just pop down here. Really simply, we can right mouse, add an anim notify event. We want to allow the rotation, which is when we let me just double check which way. Yep, so we allow for this one, and we want to block for this one. So if we go play and compile, play. Okay, and there's just only a couple more things we need to fix up for this to function properly, because when we try to rotate, you can see that it's not actually taking any input. So what we need to do is we've probably unchecked the wrong one. Ah, yes. So we need to adjust this one. Let me just pop this down. We want to orient rotation to movement. Yes, we do want that. And you'll notice there'll be it will be slow, but hang on, I think we also need to, yes, this is 50. Let me pump that back to 550. Okay, so here you can see that we're getting the correct thing, but the rotation isn't starting, so I'm pushing right, and he keeps taking this weird angle, and that's because I think we forgot to put something. Yes, see, we forgot to hook this false up into this one, so that resets that. So if we click compile, there we go. So now we're getting the correct starting animations. And as you can see, there is the rotation is very quick, which is why we actually pop this down to about 50, and we can actually just quickly write the code. It's not that complicated, and it'll actually give us a really nice look to it. So how do we do this part of it? So what we want to do first is we actually want to right click in here, and we want to get anim instance, and then we'll drag down here, and we want to cast to the custom, the one that we just created. Let's plug that in there. We want to target the speed, so we want to get that speed, and then we also want to do a greater than. So if this is greater than 0.01, then we're going to do a branch, and we're going to say that's the condition for that branch. Cool. And for this, we actually want to do this cool little thing called a do n, which will only do n one time. So we just want to make sure that only runs once. And we actually want to make this false a timeline. So we want to make this a new timeline. And let's just call this reset rotation speed. And here we go. So let's just let's bring this one up, and let's make the length 2. Let's make it a float, and we can right mouse. So we can call this the rotation speed. If you need to edit it, you can come up here and rename. Right mouse click. Let's add a key, and we're going to make the time exactly 0, and we're going to make the value. What are we going to make the value? We're going to make the value. Come on. Yeah, 3, 0, and 350. So we're going to make it 350. You can click this thing, and that way we can see it. And then what we're going to do is we're going to go from 350 down to, we're going to make the time exactly 2, and we're going to make it 50. And then we're going to click these two, and then drag. Oh, it's not letting me. There we go. So drag, right mouse click, and auto. So that way we get this nice little curve going. And let's compile that, and let's jump back to the event graph. And what we want to do now is we actually want to set, I believe, set rotation. Okay, let's just grab the character movement. I think we actually need to do it from here. Set rotation rate. There we go. And we want to split this. We want to update it, and we actually want to plug the rotation speed into the yaw of the thing. Cool. And now for the exit, we're going to do a new timeline, and this is going to be the rotation increase from start, and this is going to be play from start instead of a play, because we want this to run every time. And for this one, what we want to do for here, we're basically doing the inverse operation. So we're going to do a float, call this increase rotation speed, plug this one into here, and we're going to make the time 0, 50, and make this 2, 350, and plug, and then whammy, and make this in auto. Yeah, groovy. And again, we're going to want to do the same thing, which is grab this. We can do a reroute, make that look nice, and then plug this into set rotation rate, split the struct, update it, and then increase the yaw, which in turn we want to probably see the split, and we want to print this so we can actually see what's going on, and make this 0, and again append that, plug that into there, break this one and whack that in there, and then call this the increase rotation speed. Okay, so now if we go play, you can see that's a lot better, and that the speed, well, that's still fairly slow. Did I hook up everything correctly? No, see, we need to reset it. There we go. So we need to plug this one into here. So that way, when this runs, we enter, we do this, and then we come back, exit, and reset. So this should fix it up. There we go. So that rotation speed increases. And then, there we go. Perfect. And I'm going to try this with the controller. So here we are, we're getting perfect motion now. And if I push slightly on the stick and then let go, okay, so we're going to have to do some adjustments to the turn and places, because that's it's a little bit funny. So as you can see, he kind of spins. So that's probably to do with the animation notifies. So we can fix that up in the next tutorial. Because I think this one has run pretty long so far, and we have done quite a lot in it. And then we'll also do the jumping animations as well. So things to cover in the next tutorial will be smoothing out the whole function, because we have the whole system running quite nicely. And as you can see, we managed to block the system. I'm trying to rotate, but we're not. So obviously one of the animations doesn't have the correct setup on it. So we'll need to cover that. And then, yeah, so it must be the 180, because that seems to block it. So we'll fix that up. And we'll also fix up the turn and places, the jumping. And yeah, we'll just give it a general polish. But apart from that, we have a really nicely working system now, and it's yeah, it should be going really well. So thank you everyone for watching, and I'll catch you all in the next tutorial.